So here we are. Let me full screen. There we go. How is this form different than the row echelon form that we were getting something into yesterday?
There's zeros on top.
Zeros on top and bottom. So technically, reduced row echelon form is just a little bit further than row echelon form. Okay? So we still have a main diagonal, if you guys want to write it in words, a main diagonal of ones. Oops, I cannot spell diagonal. There we go. Now I can't spell diagonal again. Diagonal. There we go. A main diagonal of ones. And then top and bottom of zeros. Whereas row echelon form was only bottom of zeros. Now, hold on. We did row echelon example at the end of yesterday, top and bottom of zeros. It's warm in here. Flames, pause. The last example we did yesterday was just row echelon form. And when we got to the very, very end of all of our hard work, were we done? No. How would we have finished? Yeah, we would have had to back substitute to solve. Now, is it easier than it was to begin with? And the answer is yes. However, if we still have to solve our back substituting system, we have it in a stair step. That's what row echelon is called, right? If we have it in a stair step, it should be easy to solve. We're going to mental math this, and we're not going to take tons of time showing all the plug and chugging. Long story short, what do we know Z to be? Mental mathers try to keep up. Plugging in 2, right up above, we have 2 times 2 is 4, minus 4, added to the other side, y is equal to 2. Then if we plug in 2 for y and plug in 2 for z, then we end up with negative 8 plus 6 is negative 2 added to the other side, x is equal to 7. Don't worry, I have full confidence that if you guys took the time and carefully plugged in, if you can't mental math it, that you would get the same answer. Yeah?
Yeah.
But was there an extra step of still having to solve? Yes. What's nicer? Excuse me. Oh my goodness. Sorry, guys. What is nicer about our REF form? We're already there because, guys, if we can change a matrix to its identity matrix, ooh, it's an identity matrix. Hey, that's something else to take note of, right? This little guy is the identity. If we can get to the identity matrix, then question, what do we already know about x and y? Maybe write this a different way. What if I was to go ahead and, because some of you are like, wait a minute, I don't get it. Let's get rid of that. Let's write it a different way. What if, because you're going to end up row reducing and get some numbers, right? Let's say you get A, let's say you get B. Let's use letters that aren't used up above. A, B, C, D, E, F. Let's say you get F and G. Okay. What do we know about F and G? Okay, that was when you make a matrix. Question, what kind of variable is almost always in the first column? X's. What variable is almost always in the second column? Y's. And then these are our constants, right? Okay. So can't we say, according to this matrix, if we were to go back to equations, wouldn't it be 1x equals what? And wouldn't it be 1y is equal to? So don't we already have our solution? We don't need to do any extra back substituting stuff. Hence, the positives or the pros or the, what am I trying to say? Benefits, thank you, of reduced row echelon form, RREF. Now, how do we do this though? It's time for us to work a little harder. Now, wait. This is going to get overwhelming fairly quickly, so maybe we should run to one that has a system of 4 equations. Let's try a smaller one. Does that sound good? Okay. Let's try a smaller one. Now, I know you can do substitution. I know you can do elimination. I know you can do stair-step method. But let's try to go ahead and, now, hold on. Some of you are going to read these directions incorrectly. When they say using matrices, number 1, they mean by hand. You can check using your matrix function in your calculator, but remember, this test is going to have a calculator and non-calculator part. Just be ready. By hand, number 1. And number 2, let's go all the way to RREF. Sound good? Let's go all the way to RREF. We can go to REF, we can go to row echelon form, but then we still have to do back substituting. That's no fun. So let's just go to RREF. Reduced row echelon form or the Gauss-Jordan elimination. Here is, real quick, before we do our first simple example, can I give you quick pointers that we maybe should write down as quick little shortcuts of what to remember for RREF, or reduced row echelon form? Here's pointers. Here's some quick hints as to the process. Hint number 1, work by columns. You'll see what I mean as we get through examples today. Number 1, work by columns, starting with column 1, then column 2, then column 3. Get the column right. How are we going to get the column right? Work by columns, and in each column, establish the one, establish the one, then go for the zeros. Now guys, obviously this is not very precise and this is not very mathematical. This is my own personal way of saying it. But establish the one, then go for the zeros. Work by columns, establish the one, then go for the zeros. That's the process. That's the process. Using the math that we saw yesterday, as far as we can multiply an equation by a number, we can add it to another equation, etc. We can multiply a whole equation by like a fraction. Those are the steps that we're going to use. Now, let's go ahead and see if we can figure it out on this small baby one. Small baby one, where are you? Here we go. First of all, there's not a matrix yet. How do we make a matrix? Yep, coefficients, right? 1, 2, 2, 1, those are all my coefficients. I'm able to put them straight in because they're already all matched up. They're all the same like terms by columns, right? And then we have 7 and 8. There we go. Work by columns. What's the very first column, guys? Okay. I say work by columns. I have to choose the first column. What are my steps? Establish the one. Who's the one? Oh, the one's already in the spot, right? Okay, establish the one. It's already done. Now what do? Go for the zeros. I need to make the zero. Who's supposed to be 0? This guy. How can we make that guy a 0? Well, can't we say take the top row, which has a 1, multiply him by the opposite coefficient of the second row? Okay, that's something you could program into a calculator or program into a computer program. Take this coefficient, multiply this 1. Once you have a 1, multiply it by the same coefficient but the opposite sign. Okay. So -2 row 1 plus row 2. Why did I put the little arrow? Because I'm telling it where to go. Does that make sense? Thinking through the programming once again. So, taking row 1 and multiplying it by -2. If you need to, you can do this off to the side. There is no shame in showing your work. So you could actually, for instance, do that first step. -2 row 1 plus row 2. You could multiply the top row by -2. So 1 times -2, 2 times, 2 times -2, 7 times -2. And you can add that to the second row, which would be 2, 1, and 8. So if you want, you can actually set up like a little problem with it if you want to, if you need to. Then you can get your 0 and your -3 and your -6 that we're going to go ahead and put into our matrix over here. There's no shame in that. That's going to be our 0, our -3, and our -6. I'm going to be doing math a little bit quicker than that. Hence why I was saying you got your mental math caps on, or at least trust those that are better at mental math than we are. But do you guys see the process of multiplying that whole guy by -2, adding it to row 2, and then we have our 0? Yay. So work by columns. Is column 1 good? Yeah. He has his 1 where he's supposed to be. He has his 0 where he's supposed to be. Now what is it our turn to do? Work with column 2. So let's go ahead and work with column 2. Let's move this guy over. Boop-a-doop. Establish the 1. Oh, it's already done. Oh, wait. By the math of establishing column 1, what happened to our guy in that spot? Oh. So how do we make that -3 into a 1? Always division. Always division. We can divide 1 over whatever coefficient we have, once again, something that could be easily programmed once you learn how to program. We can divide the entire second row by whatever that coefficient is, and what do we have? 1, 2, 7 stays the same. 0 divided by anybody, 0. Negative 3 times negative 1/3, or divided by negative 3 is 1. Negative 6 divided by negative 3 is 2. Do I have my 1? Yep. So when we're working with the second column, kiddos, we're not working with the old second column, we're working with the new second column. So checking it out, we established the 1, good. We established the 0, he was all good. Then we established the 1, they're all good. Who are we missing? Or who do we need to still go for? Yeah, we need that guy to be a 0. How do we make that guy a 0? We look at the row with the established 1 and we say, sweet, let's just multiply you by the opposite coefficient. So negative 2, row 2 plus row 1 into row 1. If you guys need to do that math off to the side, for the last time I'll do it quick. Negative 2 times row 1. No, negative 2 times row 2, my bad. That's going to be 0, negative 2, negative 4, right? 0, negative 2, negative 4. We're adding that to row 1, which is going to be 1, 2, and 7, which will be 1, 0, and 3, right? And that's going in row 1, so we can go ahead and say, all right, cool. 1, 0, 3, 0, 1, 2. Did we get our second 0? Check. Do we have everybody good? Check. We have our identity matrix. Wait, why was that so cool? Or what did that accomplish? I know exactly that x is equal to 3 and y is equal to 2. Now some of you are like, that is so annoying, except here's the dealio. Elimination, substitution, even graphing takes an awful lot of programming to be able to do. However, the process that we just did is a systematic approach for how to solve a matrix. And that is exactly the math that your calculator is going to use when it does its feature of RREF. Now, kiddos, hold on. Have we talked about how to make a matrix in your calculator? Check. Have we talked about how to do RREF to solve for a system? Check. Uh-oh. It was actually the day before the test, so maybe some people weren't here. Remember, that was our way of having the cheater shortcut to make sure you were okay? Some people knew it, some people forgot it, and I didn't want anyone to have like an unfair advantage. Let me quickly get off the inequals because I don't really feel like having that on my calculator. Get you away. Let's type on that. Let's type that. There we go. Okay, so second x inverse. Oops, that's the wrong one. Second x inverse. Edit. What was that thing that we just made? Was it a 2 by 3? Right? Okay. What were the original elements? Okay. So 1 and 2 and 7. What was the second row? And then 2, 1, 8. Once you have that in your matrix, that's matrix A. Just remember the letter. It'll be important in a second. We do second quit. We go ahead and go back to the home screen. We go to our matrix menu and go to the math. We can go to RREF. What number is it? 9? No, it's not 9. 0? Oh, B, that's 9. Okay, alpha B. RREF who? RREF A. You could try A. I'm pretty sure it doesn't work though, because you need little brackets. It might be easier to do second matrix and go get A and say, hey, I want you. And they'll say, okay. Someone should try the brackets though. I'm curious if that works. I haven't tried that before. Oh my gosh. Whoa, that did it so fast. Why? Because computers are able to do quick operations, or I should say, are able to do arithmetic or operations very quickly, of course. But what system did it follow? Ooh. It did that really, really fast. It did that really, really fast.
So cool.
Does anybody have quick questions about how to use your calculator? Because you're allowed to be like checking with it, etc.
How did you get the A ring?
Oh, remember, go to second x inverse, and then the names, just hit enter on A.
Oh, okay.
You see it, and then it steals the name for you. Okay, so we are learning the programming behind what's gone into telling machine how to do this process for us really quickly. Luke.
It doesn't work with the brackets.
Bummer. Oh well, E for effort. I think it's faster to go to the matrix menu anyway. RREF is under second quit, second matrix map. Scroll down to B, or you can probably type alpha B. Did anybody see if there's any matrix shortcuts in our alpha y equals? Oh, not that exciting after all. I was hoping there'd be more. Row and column, that's kind of lame. Anyway, is there anything else? No. Second quit. E for effort. Let's go back. We need to do some more examples. Are we ready for the hard one?
Let's get it.
You want an easier one first? Actually, those are tricky. Is this one smaller?
Just go.
Go big? All right, let's do it.
Let's go.
Who said that?
Oh,
Mickey G?
Mickey
No.
G.
Now, kiddos, I am not, for this entire thing, I'm not going to go off to the side and like write it all out, okay? I'm just going to write the operation. I'm just going to write the operation and then go for it. Is that okay? Yep, same section. You guys should be making a matrix, by the way.
Would that W go before the Z's?
Actually, no, and here's the reason why, because we're used to X, Y, Z
Yeah.
as being our first, second, third dimension, so W is like an additional beyond. A good question, though.
What if there's two more like a W?
I don't think you're going to see two more, so we won't worry about it. But technically, if there were more, then it'd be alphabetical after that. The first name in the game is, can you actually write it correctly? Oops, why am I saying Z and Y? I have no idea. 1, 2. Now, we are allowed to rearrange if we would like. Is there any rearranging you would like to do? AKA any equation that you would rather be first. Sean.
I would think either equation 2 or 4 is first because then we would have already established the 1 in the first place.
Good. Since we're not a robot, we can go ahead and at least start a little bit easier and move 2 or 4 up. We could start with it the way it is and multiply the top row by 1/3, but Karina.
Can we just move the top row to be the last one? That way,
Yeah, by the time we do the zeros, we don't mess it up. It's a good idea though. So I'm gonna go ahead and I like this bottom row. I think he's a good one. Let's move him out. Do you wanna just move the 4th one down? Now technically we could do like a little operation for that, kiddos. We could tell the computer to look and find a row with a leading of 1 and it could do it itself. Or the computer, since it can do everything quickly, it would just follow the system with whatever is there in the first. We're just being a little bit lazy. A little bit lazy.
Did you already change that? Actually, let me see. Why wouldn't you put the 3rd one just second?
We could. Karina was asking something similar. Long story short, if we're working by columns, guys, we're not even looking at the rest of the matrix yet. Not really. I mean, we're going to use it. But what are we going to focus on first? Getting these guys to be zeros. And once we start doing operations to the whole equation to get the first thing to be 0, all of this is going to get messed up anyway. So even though some of it looks like it might go better in a different row, it really won't. Here's the cool thing is we can do lots of things at once, very carefully. For instance, I can say something to the effect of row 1 minus row 2 into row 2. Why am I doing that?
So that you get the 0.
So I can get the 0 in the original, right? I'm trying to get zeros. So if I do row 1 minus row 2 into row 2, won't that get me a 0 here? 1 minus 1? Good. What can I do to get a 0 in row 3? Did it work to multiply the first one by 2? So if I multiply him by 2 and add, won't that be 0?
Yeah.
Good. How about for the third one? Do you see a pattern as to how you start getting zeros? Don't you just multiply the first one by the opposite sign, and then I just add? Multiply by the opposite sign, and then add, multiply by the opposite sign, and then add for each of the rows? Does that make sense? So if I multiply the established 1 by the opposite sign and add, I'm going to get zeros and all the rest. Now I'm about to do a lot of mental math. You guys going to hang in there?
Yes.
All right. Am I changing row 1? Nope, he's good. Are the rest going to change?
Yep.
All right, hold on tight. I'm doing the first one first to get row 2. So I'm doing row 1 minus row 2. I'm looking at these 2 rows over here, right? I'm going to subtract each of the corresponding elements. Like, 1 minus 1 is 0. 1 minus negative 1 is 2. 1 minus 4 is negative 3. 1 minus 2 is negative 1. And 6 minus 25 is negative 19. Feel free to double check. What did I just do? Subtracted everybody. Mental mathers, anybody back me up before we move on?
Yes.
Good. How do I get row 3? Well, I follow this pattern with row 1, multiplied every element by 2, adding to all the elements in row 3. So I'm going to double all the top ones. This is going to be 2, 2, 2, 2, and 12. I'm going to add them to row 3 and then get that in row 3. So, 2 times 1 is 2. 2 minus 2 is 0. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2 plus 2 is 4. 2 times 1 is 2 minus 1 is 1. 2 times 6 is 12 plus 2 is 14. Any mental mathers back me up? Last but not least, I'm going to do the top row, every element times negative 3 plus row 4. Every element times negative 3, adding them to row 4 to get that 0 down there. 1 times negative 3 is negative 3 plus 3 is 0. 1 times negative 3 is negative 3 times plus 2 is negative 1. 3 minus 1 is negative. It's negative 3, right? Yeah. Negative 3 plus 1 is negative 2, and negative 18 plus 0 is negative 18. Mental mathers, how's it look? Woo! Column 1. Guess what? Done, right? Column 2. Column 2. Let's establish the 1. Now some of you are like, but wait, can't we maybe move the 4th row to be the 2nd row?
Yeah.
Could we? Yeah. Could you just divide everybody by a half? Yeah. Which one sounds more fun? Divide everybody by a half, or move this guy to be row 2 and multiply by a negative? Either one. We gotta pick one altogether though. What do you guys want to do?
Move.
I did the half.
Move. Move.
I wrote it.
Let's not have fractions yet.
Sean's going big or going home, so let's go big or go home with him. Ready?
So ugly though.
All right.
It's a beauty. Beauty for math. Y'all should know this.
We're doing 1/2 of row 2 into row 2. Don't worry, eventually there will be fractions anyway. There's not much avoiding. So, long story short, we have 1, 1, 1, 1, and 6 for row 1. 0 divided by 2 is still 0. That's nice. He stays. Exactly. That's why we do it in this order, so that the 0 stays. 2 times a half is a half. Negative 3 times a half is negative 3 halves. Negative 1 times a half is negative 1 half. And technically, the calculator would have just divided by 2 anyway, so Sean's being a calculator. Go team.
Okay, Sean.
Negative 19 divided by a half. There we go. Because calculators aren't scared of fractions.
I'm a human.
Computers aren't scared of fractions. Computers, like hidden figures. Exactly.
Oh, you are such a
Be brave.
That was
Okay,
such a-
so, coming back. Such a good one.
Yeah, well,
Calculus AB kind of gets to see the Euler's method that she used to solve, which is kind of fun.
that was so cool. Yeah, that's so
Row 3 didn't change, did it? Row 4 didn't change. But now is it time for rows 1, 3, and 4 to change?
Yeah.
Yeah. We have our established 1, right? What do we need?
Why don't you do row 2 minus row 4 plus row 4?
Yeah, we can do that. But what are we going to do for row 1? What do you guys want to do? Row 2 minus row 1 or row 1 minus row 2? Can we do that though? Is that going to mess us up right here? If I do row 2 minus row 1, won't I have a negative 1?
Yeah.
So I better do row 1 minus row 2, huh? Or you could do negative row 2 plus row 1. Either way. Row 1 minus row 2 into row 2. Nope. Into row 1, thank you. Row 2 is fine, leave him. Row 3, can I do negative 3 row 2 plus row 3 into row 3? Row 4, can I do, row 2 plus row 4? Into row 4? Got it. Whew. Row 2 stays the same. 0, 1, negative 3 halves, negative 1 half, negative 19 halves. Alright guys, get your big boy pants on. We're going to have to be strong. Be brave. It's about to get exciting. Why? Because we're multiplying by fractions and adding. Woo! Alright, for the first one, row 1 minus row 2. Top minus bottom. 1 minus 0 is 1. 1 minus 1 is 0. There he is. 1 minus negative 3 halves. 1 plus 3 halves. That's 5 halves. 1 minus negative 1 half. 1 plus 1 half. That's 3 halves. 6 minus negative 19 halves. That's 6 plus 19 halves, which would be 18 plus 19, 27 halves. Double check me though. 18 halves. No, 12 halves. What am I thinking? It's not 18 halves. I was multiplying by 3. 12 halves plus 19 halves is 21 halves. Is that better? Uh-oh. Don't let me lose you now. Mental math, there's someone has to double check me. Think of all the ones as 2 halves. It makes lives easier. 2 halves plus 3 halves. 2 halves plus 1 half. 12 halves plus 19 halves. I just said 12 plus 19, didn't I? Uh-oh, do we have no mental mathers in here? Where'd you guys go? It's 31 halves. No one double checked me? How did I lose you? Alright, now we're multiplying row 1 by negative 3. I'm assuming I'm good because no one's saying anything, but that's so dangerous. Negative 3 times row 1.
Row
Oh, row 2, sorry, good. Negative 3 times row 2, that's better, right? Because negative 3 times 0 is 0, and 0 plus 0 is 0. Negative 3 times 1 plus 3 is 0, nice. Negative 3 times negative 3 halves is 9 halves, plus 8 halves is 17 halves. Negative 3 times negative 1 half is positive 3 halves, plus 2 halves is 5 halves. Negative 3 times negative 19 halves is positive 57 halves. 57 halves plus 28 halves, which would be 75 halves.
Yep.
Is that a Yasha?
No, it's 85 halves.
85 halves?
Yeah.
Okay. I did it too fast. 9, 7, 57, and 57 plus 28. Oh yeah. Why do I keep on not carrying the 1 in my head? Struggle. I did that twice now. 85 halves. Row 4. Whew, this one's easier. Just row 2 plus row 4. Okay, good. So 0 plus 0 is 0. 1 plus negative 1 is 0. Negative 3 halves minus 8 halves is negative 11 halves. Negative 1 half minus 4 halves is negative 5 halves. Negative 19 halves minus 36 halves would be 55 halves, right? Did I carry my 1 this time?
Yes, okay.
Negative 19 minus 36 halves for that last element. If you guys notice, I'm getting the whole numbers to be halves. That'd be negative 40, negative 55. Good. That was gross, but do we have column 2? Whew. Yes. Yes, we do. Now it's messy, but what is it time to move on to? Okay, so we got column 1, we moved on to column 2, now it's time to move on to column 3. Now, what do I need to establish? I need this guy to become a what? A 1. Alright, well, oh, don't I just multiply all of row 3 by 2 over 17? 2 over 17, row 3 into row 3.
Oh my gosh.
You guys said you wanted numbers like all year.
Let me decide.
Okay, top row stays the same. Should probably write these closer together. I'm gonna run out of room real fast. No, please, if you guys see something, let me know, otherwise we'll be in trouble. I'm leaving the 4th row too, right? Okay, multiplying the 3rd row by 2/17. Yeah, anything times 0 is just 0, right? So we can say 0, 0, 2/17 times 17 halves. Ooh, that's nice. There's my 1. Da, 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 da. Oh, keep going. 5 halves times 2/17, that's 5/17.
Yes.
2/17 times 85th 17. Wait a minute, the 2's cancel. 85 over 17 is 5. What?
Ooh.
85 over 17 is 5? Yeah, it is. What's it our time now to do?
Get them zeros.
Let's get them zeros. Like, multiply negative 5 halves times row 3 plus row 1 into row 1. Oh my goodness. Multiply 3 halves times row 3 plus row 2 into row 2. Oh my goodness. 11 halves row 3 plus row 4 into row 4. But do you guys see how there's a system? Please tell me you say yes.
Yes.
You're just multiplying the established one row by the opposite coefficient of the other rows and then adding. And the nice thing is, if we did it right, which we did, this'll stay, this'll stay, this'll stay, and this'll stay. And hey, row 3, we're not even changing at all, right? Now what's about to get fun? Woo! All the rest of it. Cool kids! Oh no, we're out of time! Alright. We got stuck on a really long one, but that's okay because we just went bigger, went home, right?
Yeah.
Yeah.
We went bigger, went home. Tonight, work on this homework, like literally, work on it. But come in tomorrow and we'll probably finish some examples. We'll start 8-2 tomorrow, but we won't necessarily get very far on 8-2. So, work the best you can on 8-1. Why did the bell ring? I just
It should have been.
it should have, right? Alright, get out of here. Work on 8-1. Do not save it till tomorrow. Please do not save it till tomorrow. Bye, guys. Go rest your mental math skills.